What's going on, fellow flight crew members? Flight Medic Barry. We are Wheels Up 10-8 in service for our final episode of our O2 duration calculation mini series. If you haven't seen the first one, it's on Instagram, 90 seconds, really easy to digest, but builds upon the principles and foundations that we're going to talk about today, where I ask you this question. What if you do if your flow rate from the equation in part one is X? We don't know it. We could ascertain our flow rate through the use of a couple of metrics on our ventilator in order to find our flow rate. Now, you may ask, when would ever this be pertinent? Well, if you have an intubated patient for one, and you may say, well, most ventilators give us our flow rate, and I will tell you that we're not going to get out of that one so fast because there are a lot of ventilators that are still out on the market that do not give you this straight up, which means we have to ascertain it and we have to calculate it on our own. And I have run into this situation blindsided when I was used to Revels, and then I went to another unit that I will just amend from speaking about, which did not give me these metrics, and I had to learn the hard way, and I had to do some retraining. And so hopefully this will serve as to ensure that you don't make that same mistake. So we our equation here is flow is equal to tidal volume time, or divided by our I time. And so let's play this out. So we have a 450 ml tidal volume patient set on volume, and we have a 1 second I time. So we want to sidebar here, end this whole equation in liters per minute. So we can turn our mLs into liters pretty quickly with 450 liters with that decimal, and then we have 1 second. That gives us liters per second. Cool. Now, how do we ascertain our minutes? Easy. 60 seconds in a minute. We seconds cross out. That leaves us with 27 liters per minute. You would say, everybody, it's time to clock out and check out. We are done. Well, not quite, everybody. We are almost done. Now we have to take this metric and put it in that flow rate calculation from part one. That's why it's important, so that we can tie these two parts together. So we will just play off of part one and say we're using a D cylinder, which is a conversion factor of 0.16. We times that by, say, there's 1500 psi in the tank, and now we've gotten our 27 liters per minute flow rate. And what does that give us? That gives us 8.8 repeat. And so what does that tell me? We have a 8.8 minute duration on that tank before we need to switch over. So I wouldn't say 8.8. Obviously, we round closer down to be more conservative. We don't want to say 9, because we're kind of basically giving the patient time that's not really there, and we're counting on time to conserve that point 2. So be conservative. This is applicable for those who are doing rural long distance transports, those patients who are very heavily dependent on O2 and that need a lot of O2. And this could be even something that we calculate in our original equation in order to determine if we're going to need to intubate, because the patient is just taking in too much and we won't have enough. And so intubation, we can use that to maybe conserve the flow in order to conserve the duration of time on our tank. So ladies and gentlemen, we are now 10-7 out of service. I'll see you on the next series. It's Flight Medic Barry signing off.